Yes, my voice is clear.
Yes, sir. Yes, sir. Yes.
Okay. Okay. So once again, good afternoon to everyone. Okay. So for today's lecture, we can revise the things. So what we learn the starting of unit number 3. Okay. So for today's lecture, we'll just take a revision of a point processing and different types of point processing. Okay. So everyone listen carefully. So we can cover the first point of unit number 3, that is a point processing. Okay. So in point processing, we can study what is a spatial domain, what is a point processing, and what are the different types of point processing, and what are the applications in which field this type of processing can be used. Okay. So simply we can take a revision up to the image. uh, First point is image negative contrast stretching, right? So, okay. So basically, what is the image enhancement? So can anyone tell again what is the definition of image enhancement? Hi, Lakshat.
It is the process of clearing image.
Very good. Sanjay Lakshay. Okay. So the image enhancement is
Last
nothing
time
but,
also.
okay. Oh, असंच राहू द्या. Okay. So the image enhancement nothing but the process of improving the appearance of image. That is the image enhancement. So it can be used in any application. So depending on application, we can improve the quality of image. So for that, we can take the example of healthcare system. Okay. Okay. So basically, again, we have to discuss what is a image enhancement and what are the different types of image enhancement methods. Okay. So basically, there are two methods which can be normally used. One is a spatial domain method, and another is a frequency domain methods. Okay. So everyone again try to listen carefully. So in a simple way, in a single lecture, we can discuss the first point, that is the point processing. Okay. So it is a revision for you, and might be you get a more idea regarding the point processing. So before point processing, we have to study what are the different methods that we have to study in an image enhancement. Okay. So basically, we have to study the two methods. One is a spatial domain method, and another is a frequency domain method. Okay. So always remember it. What is the mean by spatial domain method, and what is the mean by frequency domain method? So in spatial domain method, we can deal with an individual pixel of the image, and in a frequency domain method, we can consider the various types of transforms that are applied on the images. Okay, so along with these two techniques, we have to study the classification of image enhancement. So what we have to study in a classification, what are the different types, so how it is classified into uh, such a type, such different types. So if we have to deal with the individual pixels, so that is nothing but a point. So that's why we can call as a point processing. Again, if we deal with the various types of noises, yeah, in order to remove such type of noises, we can use the various types of filters. So for that purpose, we have to study the various types of filters. There is high pass filter, low pass filter, right? So along with this filter, we have to study the one important type of filter, that is a homomorphic filter. Okay. So the homomorphic filter, how the noise can be removed by using these type of filters, what is the importance of homomorphic filter, what are the applications of homomorphic filter, so that we have to study in these type of techniques. Okay. So now we discuss the various types of point processing. So can anyone tell me what are the different types of point processing? फक्त हे चारच आहेत का? Which type we can discuss up to it? Yes, can anyone tell all the points? कोण सांगते सगळे पॉइंट सगळे टाइप्स? Yes, can anyone tell? ओमकार साळुंखे.
हाँ सर.
What are the different types of point processing? कोणते कोणते टाइप आपण स्टडी केले? Okay, yes, anyone? एक पण नाही सांगता येणार. ऍटलीस्ट स्लाइड वर दिसतात तेवढे तर. जरा सगळे विसरलात का? चलो कोण सांगताय? कोणते कोणते टाइप आपण स्टडी केले? You can study 7 to 8 points, 7 to 8 types. So can anyone tell me the names of the types? Out of that, 4 are visible on your screen. There is the image negative, contrast stretching, thresholding, and brightness enhancement. So along with this, we also study 3 more types. कोणते आहेत ते? झाले सगळे विसरले. युनिट नंबर 1 मधलं काय लक्षात आहे का मग? संजय. रोल नंबर 32. सांगता येईल का? 32, 34. भूषण. माझा आवाज येतो का व्यवस्थित सगळ्यांना? Am I audible to everyone? Hello? My voice is clear? It's roll number 8. Okay, my voice is clear? काय झालं सगळ्यांना? हॅलो? एक जण अनम्यूट व्हा कोणी तर, इन्स्टेड ऑफ पुटिंग मेसेज इन चॅट बॉक्स. एवढा कंट्रोल आलाय? Amit, row number 35. प्रथमेश कुलकर्णी,
Yes, sir.
कंटाळा आलाय का? कोणाचा रिस्पॉन्सच नाही आहे. Okay, mute yourself. Okay, so I hope everyone listen carefully. So Amit, mute yourself. Okay. So now everyone try to listen carefully. So we'll revise the various types of point processing. Okay. So the basic idea of a point processing operation is that we can deal with various individual pixels. Okay, so that is nothing but called as a pixel intensity. Okay, so as we consider a single image, it consists of number of rows and number of columns. So if we consider image as a size 256 by 256, then it having 256 rows and 256 columns. Okay, so the values on that particular image can be ranges from 0 to 255. मग ह्याच्यातले काही जे काही नंबर्स असणार आहेत, so that number can be ranges from 0 to 255. So 0, 1, 2, 3 up to 255. Okay, so at a single point is represented, yeah, the single point is referred as a pixel. Okay, so as the points move from the 0 position to 255 position, then the intensity level can be increased. Okay, so why? Because we can represent 0 as a black, right? And what is a maximum pixel that can be represented as a white? Okay, so that concept we can study in a contrast stretching. Okay, so as we changes the point value, either it might be from 0 to 255, the intensity of that particular image also changes. Okay, so here we can study the first technique, that is the first type, that is called as the image negative. Okay, so basically what is the image negative? So in image negative we can take simply the reverse action. Okay, so if we consider the black and white image, so it consists of only two colors, right? One is a black and another is a white. So if we apply the image negative on such type of image, then we can convert the black color into the white color and the white color into the black color. Okay, so if we take the examples of the images, okay, so here we can take a one image and we can apply the image negative. So if we compare the original image and the image negative, then we can observe what are the black color, that black color is converted into the white, and what are the white color that can be converted into the black. Okay, so it is the concept of image negative. So the simple application of image negative can found in a healthcare system is that it can be used in a uh, yeah, it can be used to capture the x-rays of our human body. Okay, so the x-ray is the best example of image negative. So along with this we can also take more images to more clear the concept of image negative. Okay, so the second concept is that contrast stretching. Okay, so as we discussed earlier, as we deal with the point processing, we can deal with the individual pixels. So here we can consider the example of one image which having a size of 256 by 256. Okay, so as we mentioned any size, okay, to mention that particular image, we can always start with a 0 pixel value. Okay, so as the image is 256 by 256, so it can ranges pixel from 0 to n minus 1. Okay, so if the image is 256 by 256, so n minus 1, that is a 256 minus 1. Okay, so is equal to 255. So we can represent the range as a 0 to 255. So in this case, so the contrast stretching nothing but it can consider the brightness of that particular image. So we can change the color, we can change the brightness by using contrast stretching. So we can increase the brightness, we can decrease the brightness. Okay, so it's depending on its pixel position. So if we ranges the pixel from 0 to 255, so if we observe the slide, so as we move from 0 to 255, the we can observe there is a change in intensity. So at the 0, there is a total dark color, and at 255, there is a total white color. Okay, so if we moving from 0 to 255 pixel, the intensity of color can be increased. And in reverse way, if we can decrease the intensity, yeah, if we can decrease the pixels from 255 to 0, then the intensity of image can be decreased. Okay, so it is the concept of contrast stretching. So the contrast stretching nothing but increasing and decreasing the brightness in the image. Okay, so here we can take the example of contrast stretching. We can take a one original image, and on that original image we can apply the contrast stretching. So due to this, we can improve the quality of input image. So the original image is not able to visualize properly. So in order to highlight the part, or in order to improve the brightness, we can apply this enhancement technique, that is a contrast stretching. Okay, so due to this, we can observe the object clearly. Okay, so the third concept is that image thresholding. Okay, so what is the image thresholding? So the basic function of image thresholding is that it can subdivide the image into two parts. Okay, so what are the two parts? So depending on the threshold value, we can subdivide the image into two parts and make the white part of the image more white and the black part of the image more black. So if we observe the image, we can get the idea of thresholding. So in the original image, so what are the white part? So we can select any one as a threshold value. So if we consider the image which having size 256 by 256, and if we consider the 150 is a thresholding point, so below 150 we can consider the black image, and the above 150 we can consider the white image. So the thresholding due to thresholding, we can subdivide the image into two parts. Okay, so the black color can be more dark, and the white color can be more bright. Okay, so it is the concept of image thresholding. Okay, so next, समजते का था? Okay, so just try to rememberize the thing. So if again anyone have a doubt, then you can interrupt me. समझते हैं? इमरान, किरण पाटिल, 57. किरण पाटिल there? समझते हैं ना? काही लिंक लागते हैं का?
Yes, sir.
Okay, so
Hoy, sir.
okay, if you have any doubt, then you can ask here. Okay, so next is the intensity level slicing. Just we can in a short we can brief the concept of various types of point processing. Okay, so next is the intensity level slicing. So in intensity level slicing, we can consider the particular region of the image. Okay, so if we have to improve the particular part of the image, so in that case we can use the intensity level slicing. So if we take the example of intensity level slicing, so here we can take an example of one window. Okay, so inside of window there is a total black color. Okay, and we have to improve only that particular area. Okay, so in this case we were not considering other part of the image. We can only deal with a particular region. So here we can improve the brightness of that particular image, yeah, sorry, the brightness of that particular region by using intensity level slicing. Okay, so if we observe the two diagrams, we can easily identify the change. So what are the inside color of that particular window is a total black. So we can only improve that particular area. So it is possible due to the uh, intensity level slicing. Okay, so along with this intensity level slicing, so if we have to uh, increase the intensity of multiple part on our images, so at the same time, okay, so we can use the intensity level slicing. So by using intensity level slicing, we can consider the different regions or the different parts of an image. Okay, so using this gray level slicing, we can consider the multiple regions from the single image. So as we consider the different regions, so here we can consider four types, that is A, B, C and a D. Okay, so in this case we can highlight only that particular gray levels. Okay, so uh, if we take an example of one image, let us consider the image having a size of 256 by 256. So if we make the four parts, four regions, so first one is might be 0 to 50, 50 to 150, 150 to 200, and 200 to 256. Okay, so by using this small part, we can also improve the brightness of that particular region. So the brightness may be different at the particular value. Okay, so by using this gray level slicing, we can consider the multiple regions from the single image. Okay, so here we can observe the various regions. So if we divide the image into the four regions, the four parts, so that are represented by a curve 1, curve 2, curve 3 and curve 4. Okay, so it is the output of curve 1. So might be we can consider the small pixel values, might be a 0 to 50. So in next case again we can consider from the 50 to 150, 150 to 200 and the 200 to 255. Okay, so we can consider the different regions, okay, in the gray level slicing. Okay, so the next concept is the bit plane slicing. Okay, so in a bit plane slicing, so always we can represent the image in a bit size. आपण जी image represent करतो, so the smallest unit to represent the unit is a it might be represented in a bit. So we can consider the kilobyte image, megabyte image, gigabyte image. So the smallest unit is a bit. So if we consider the grayscale image, so it can be stored in a size of 8-bit unit. Okay, so similarly we can consider the color image. We can store the image, color image, yeah, the color image having the size of 24 bits. Okay, so always remember it. If the if we consider the grayscale image, so that is represented by a 8-bit unit, and if we consider the color image, that is represented by a 24-bit. Each color can be represented by a 8-bit unit. So 8 plus 8 plus 8, nothing but 24. Okay, so that's why the color image can be called as a full color image processing. So if the any image consists of 24 bit, then it can be called as a full image processing. So might be there is a questions for MCQ. So what is a full color image processing? Yeah, the RGB color image can be represented with this bit size. Okay, so the RGB color image can be represented with a 24-bit unit size. Okay, so if we consider the 8-bit unit size, that is a bit plane slicing, we can consider the different planes of that particular image. So if the bit size is 8, so it having the 8 different planes. So how we can represent such type of planes? So we can consider the range of planes from the 0 to 7. So as it is a 8-bit, and we can consider uh, the starting point as a 0. So from 0 to 7. So these are the total 8 planes. Okay, so if we consider the one image, so we can take the example of cameraman, and we can divide that particular image into the 8 different parts. म्हणजे काय, 8व्या प्लेनला इमेज कशी असेल, 7th ला कशी असेल, 6th ला कशी असेल, 4 3 2 आणि 0. Okay, so if we consider the LSB bit, that is the least significant bit, सगळ्यात लहान bit कोणता आहे तो 0. So at this bit we are not able to visualize the image properly. So as we changes the bit from 0 to 1, 1 to 2, 2 to 3, then the image will be look better, and at the 7th plane we can visualize image more clearly. Okay, so by using this bit plane slicing, okay, so we can consider the individual planes of that particular image. Okay, so it is a 8-bit, so there are 8 different planes. If there is a 24-bit, there are 24 different planes. Okay, so by using this bit plane slicing, we can consider the individual planes. Okay, and the next concept is that the brightness enhancement. Okay, so it is a concept of brightness enhancement. So by using brightness enhancement, we can increase the brightness of a particular part of the image. Okay, so if we consider the one image, so here we can take a one image, so it having a one white point. So if we increase the intensity of that particular white point, then it can also reflect its intensity on its background also. Okay, so by using the brightness enhancement, we can increase the brightness of a particular point, of a particular part of an image. Okay, okay, everyone understood the concept of brightness enhancement? हाँ, समझते का?
Yes, sir.
Okay. Okay, so along with this concept, we have to study, yeah, we can also study the two important transformation. One is a logarithmic transformation and another is a power law transformation. So anyone can tell me the concept of logarithmic transformation? Yes, so it is a concept of logarithmic transformation. Okay, so for that we can take the example of our graph paper also. Yes, anyone? Yes, लेक्चर फक्त वन वे चालू ठेवायचं आहे. रोल नंबर 11. $37, Upendra. $51. Yes, can anyone tell me the concept of logarithmic transformation? Upendra? It is a logarithmic transformation. By using a simple example, we can define the logarithmic transformation. आठवते का? क्या स्टडी करते कि नहीं? Rule number 3. Okay. Okay. So everyone listen carefully. So we'll revise the concept of logarithmic transformation and power law transformation. So basically, what is a logarithmic transformation and what for what purpose we can use the logarithmic transformation. So by using logarithmic transformation, we can represent a wider range into the smaller range. Okay. So what are the object which having a total long distance or the wider range. So that wider range we can represent it on a small plane. Okay, so if we capture the image of galaxy, so the galaxy having a long distance from us, so we can also represent that uh, galaxy on a simple plane. Okay, so we can take the example of graph paper also. So in graph paper we can consider the small scale. So if there is a large scale, so we can consider 1 centimeter equal to 10 point, 1 centimeter equal to 100 point. Okay, so that's mean we can compress the large range into the smaller range. So again, if we observe the electromagnetic spectrum, so there are the different range of frequencies. Okay, so that different range of frequencies we can represent it on a one by using a electromagnetic spectrum. So it is a simple representation of all the frequency range. Okay, so the wider range can be represented by a smaller narrower way, that is called as a logarithmic transformation. And the another type of transformation is that power law transformation. So the basic aim of power law transformation is that, so if we capture the image by using a different objects, sorry, by using different types of devices, so for that purpose we can use the logarithmic uh, power law transformation. So we can take the three examples. So as we capture the image by using camera, as we capture the image by using a digital camera, and as we capture the image by using a telescope. Okay, so what are the inside part of these three devices might be different. Okay, so it having a different pixel resolution, it different values. Okay, so by using these we can capture the images by using a different devices. And the most general use can be found in a CRT tube, that is a cathode ray tube. It can be also used in our television. Okay, so it is a concept of logarithmic transformation and power law transformation. Okay, so everyone understood it? Yes or no?
Yes, sir.
Okay, so here we can complete the first point, that is a point processing. Okay, so the next point is the neighborhood processing. So it is a neighborhood processing. What are the different types of neighborhood processing? So that we have to study in a second point, that is a neighborhood processing. Okay, so today we'll stop here. So in today's lecture we can just review the starting of unit number 3, that is a point processing, and it's a different type. So in exam always there is a question on point processing. Okay, so it might be uh, asked individually on any technique. So there is a short note on logarithmic transformation, there is a short note on power law transformation, or it might be asked write a short note on image negative contrast stretching, bit plane slicing, and intensity level slicing. Okay, so this point processing is important as per your exam point of view. Okay, any doubts? And if you have any doubts, immediately you can ask here also. आणि थोडं जरा रिस्पॉन्स करत जावं लेक्चरमध्ये. It should be not look like it is only one-way communication. Okay? काय समजत नसेल, so immediately you can ask here. Okay, so now you can put your numbers. Okay, so put your numbers in a serial way. Start with roll number 1. बरं ठीक आहे, ज्यांनी रोल नंबर पुट केले ते लेफ्ट होऊ शकता.